Hello everyone. Today I will be talking about a very powerful C++ library called Eigen. Eigen is a C++ template library for linear algebra calculations. People are using Eigen library for various linear algebra computations in their projects, and many popular projects like TensorFlow, robot operating system, point cloud, computational geometry, to name a few, those who are using Eigen library for their linear algebra computation. Now the question is why Eigen library is so popular, why all the packages are using Eigen library. The reason being that it's very versatile library. By versatile I meant that you can have any shape and size of matrices in Eigen library. Further, those matrices could be sparse or dense, but Eigen library could efficiently handle those kind of matrices as well. Secondly, Eigen library is very fast and reliable. People have been using Eigen library for years. However, they did not face much trouble using Eigen library. The results obtained using Eigen library were also reliable. And the reason that the Eigen library is fast because Eigen library uses lazy evaluation whenever possible. If you are not aware of what lazy evaluation is in the context of Eigen library, please go and Google it. And then it also allows intelligently removing the temporaries while computing different matrix multiplications. So these are the reason that makes Eigen library so fast. Thirdly, Eigen library is very easy to use. Those who ever used MATLAB before coming back to Eigen library will be very easy because most of the time the concepts will be remain the same. So in Eigen library like MATLAB we can have a matrix defined dynamically, we can also have a particular row to be extracted from the matrix. These are possible in Eigen library as well. Also we can have a particular block of a matrix to be extracted from the matrix. We can also concatenate two different matrices, we can concatenate vectors, and we can also reshape matrix. So you can understand that all possible different linear algebra operations can be done in Eigen library. And if you are using Eigen library in C++, the using is very simple. All you need is that you need to go to the Eigen library website, you download the zip folder, all the source codes and header files will be there. You just need to download them, extract those source codes and header files, and in your code you only need to import the header files. You do not need to build the package at all. So that is another advantage of this popularity behind using Eigen library that is being used by multiple different projects. In order to compile any code that uses Eigen library header files, one just need to show the path where this Eigen library header files are located. So if you are using GCC to compile your C++ code, you can use the -i option and then provide the path of this Eigen library, and the compiler will be able to find out where those where the Eigen library header files are located, and your code will be compiled without any error. Finally, in Eigen library there are two main data types, one is matrix and another one is vector. However, in matrix and vector there are two different classes of variables that you can define. One is dynamically defined matrix and vectors. So in this case the size of the vectors and matrices are determined dynamically. On the other hand, there is another option in Eigen library to define fixed size matrices and vectors. So if you are using any vector or matrices of size less than 5, that means if your matrix dimension is 1, 2, 3 or 4. So in those cases you can use the fixed size matrices. However, if you are not sure of what will be the matrix dimension in the middle of your computation that will be appearing, in those cases it is recommended that you use matrix dynamic size variation. So, in this particular tutorial I will be using matrix XT and vector XT data types in Eigen library, because these two data types are the one which can allow dynamically size or allocate memories for a matrix and a vector. Okay, now that we have learned about why Eigen library is important and what is utility, let us now write some codes. So, in this particular tutorial I will be talking about how to create dynamic matrix and vector initializations. Then I will be showing you how to obtain the shape of a matrix and a vector. Further, I will show you what are the different ways to do matrix multiplications, matrix vector multiplications, then how to access elements of a matrix, whether you should access it element by element, or whether you should access elements as a row, as a column, or as a block matrix, like that, how to concatenate two different matrices and reshape matrices, those examples mainly. So, let us dive in, let us start writing our code. We will start first including the IO stream. So, we will type hash include IO stream, then we will include eigendens. After that, we will say we will be using namespace std. We will also be using namespace eigen. Then we will start our main code. Okay. Okay. So, our first example would be how to initialize a dynamic matrix. In order to do that, we first need to invoke the eigen namespace, and then we have the scope resolution operator, and after that we say the data type matrix xt, and then we define the name of the matrix variable. Now, if you look at this matrix xt keyword, in here this capital X says that this is a dynamic data type, and this small d is for the, and small d is denoting that the coefficients of the matrix that we are going to define will be of double type. And then we have the name of the matrix, and we are defining the size of that matrix to be 2 rows and 3 columns. Once we have that, we then need to provide the coefficients of the matrix, and then we just need to print out what, to see what that matrix is. Okay. So, we will say suppose M1, matrix M1 is equal to, so in this operator is overloaded for this matrix xt class. So, you do not need to worry about their usage. Eigen library handles the meaning of that operator in the context of Eigen library. Okay. So, we have our first piece of code ready, where we have initialized a dynamic matrix and we have filled in the spaces of that matrix with some numbers. And as you can see here, the first row of the matrix will be 1, 2 and 3, and the second row will have the elements 4, 5 and 6. However, you do not need to have these enter here, because I have a enter I have inserted an enter here to get these 4, 5, 6 in the second line. However, I could have them like this, and Eigen will still be able to identify how I want that matrix to be, because Eigen fills the matrix M1 in row wise. So, it will first populate the first row, since it has 3 elements in the first row. So, it will take 1, 2 and 3 first, and then it will, once that first row is filled, it will then come to the second row and start filling the second row. And after filling the first row with 1, 2 and 3, the second row will be filled with 4, 5 and 6. So, if you just provide your input in one line, that will also be fine. You do not need to provide the input in 2 lines as I had initially. However, I prefer it to be given like this. It is because it is easier for me to visualize how the M1 matrix would look like in its output. Now, let us see how to compile this code using Eigen library. So, in order to compile the code, I need to type G++, then I will compile the code with C++11 standard. After that, I will invoke the -i option, as I have already mentioned. Then I will provide the path of this Eigen library, and as you can see that this dot is indicating that the folder is inside in the same the Eigen folder located in the same place where this code file is located. So, I have this dot and this file folder Eigen folder name. After that, I have to say -w -o, then the name of the executable, say it is Eigen basics, and the name of the file is Eigen basics.cpp. And then, as you can see that the code compiled properly, there is no error, and then we can run the code or run the executable that was generated. So, if we do that, then we see that the matrix M1 is generated and is printed here. Okay. So, we can find out that how to describe a matrix and how to print out a matrix so far. Okay. Now, we will see another example where we will be trying to find out what is the number of rows and what is the number of columns of this matrix M1. So, for that, if we suppose want to type those numbers, then we say stdc out, then size M1 will be M1 dot rows method, and then suppose we also are interested in finding how many columns M1 has. So, for that we will invoke the M1 dot calls method and say we want to compile this code again to see the number of codes and the number of columns and the number of rows in M1. Okay. So, we see that this M1 matrix has 2 rows and 3 columns. So, we are good so far. The next example is how to initialize a dynamic vector. For that we will be again invoking the eigen namespace, and for dynamic vector we will be using vector xd, then we will say v, and we are giving the name of the vector, suppose v1, and suppose in that vector there are 3 elements. So, I will type 3 here inside the parenthesis, and then we will fill up the blocks of the vector v1, and the coefficients of that vectors are suppose 2, 1 and 2. And what we will do now, we will do the same thing, we will now print out how the vector looks like. So, we'll just change the name, and we will compile our code again, and we see that the vector v1 is created, which has its elements 2, 1 and 2. Now, suppose we want to see the size of this vector. So, in eigen you can see the size of the vector, although the vectors are one dimensional, you can still call the rows and columns method for a vector as well. So, all you will get for column is that it will have the number of columns is equal to 1 and the rows equal to 3. Okay. So, we will compile the code again, and then we will run the executable, and we see that yes, vector v has size 3 rows and 1 columns. Okay. So, we now understand how to initialize a dynamic matrix, how to initialize a dynamic vector, how to identify their sizes. Now, suppose we want to perform a matrix vector multiplication. Okay. So, we now have a vector and matrix already defined, and we want to perform a matrix vector multiplication. And when we do the multiplication, we do not suppose know beforehand what will be the new size of that matrix or vector B. So, what we are going to do now is we will describe another matrix xd, but we will not define its size. Instead, we will just provide the name of that matrix as P1, and we will say P1 is equal to M1 times V1. Again, for this matrix and vector eigen library, inside the eigen library, this star operator is overloaded. So, it identifies that whenever I have this star symbol inside a matrix and a vector, I have to perform matrix vector multiplication and not a regular element by element multiplication. Okay. So, we have the product P1 now, and if we want suppose to print P and its size or how many rows and column it has, then we will just change the name here that we already had. We will just substitute V with P's, so that we can see the output P and how many rows and columns P has, P1 has. Okay. So, we will compile the code and run the executable, and we see that P is now a 2 by 1 vector with its element 10 and 25, which is obtained by multiplying M1 with V1. Okay. So, that is also something useful. Next is how we can access different element of a matrix in a for loop. So, since suppose we have this M1 matrix here, which is a 2-dimensional matrix, and if we want each of the elements of the matrix M1 to be seen. So, we need two for loops, one will for going over the rows of the matrix M1 and the another one is for going over the columns of this matrix M1. So, we will be accessing elements of a matrix. For that, what we will be doing is we need two for loops, as I already said, I is equal to 0, I is less than M1 dot rows. So, index I will be iterating over the rows of the matrix M1, and inside this for loop we will have another nested for loop. In that case, we need to define another variable j, which will be iterating over the columns of the matrix M1. And then we will be printing out all the elements of the matrix, suppose. So, for that we need to format the printing statement little bit. So, we say M1, then open parenthesis, then we say the ith row and jth column element. That is what we will be looking in every iteration. We will have the value M1 I comma j, and that should be it. And I think we need one space just for the clarity of the printing, so that they are well separated. So, I just need one line. So, we will compile the code again, run the code, and we see that it has nicely printed the different elements of the matrix. So, it has started from the element 0 0 and ended at element 1 2. It is a so the matrix M has, it is a 2 by 3 matrix. So, its first element is the 0 0 and the last element is the first or 1th row and second column, because so this 2 is indicating the third column. So, I think you already understand why these indexes are like this. Okay. Next is how to extract a block from a matrix. That is something we will look at now. Extracting block. Now, when we are extracting a block, the syntax is little confusing if you are not aware of it using it before. So, let me name that block matrix be MB1, because we will be taking a block B from the matrix M1. So, I have given the name MB1, which is intuitive, and what we will do now is we already have the matrix M1, and then we will invoke the block method of matrix M1, and then the first thing we So, this block method takes 4 arguments. The first argument is the starting index of that block that we want to extract. Suppose the starting row index is 0 and the second is the starting column index, and then the size along the row that we want to go to extract the block. So, suppose we want to go 2 steps in along the row and 2 steps along the column from the 0 index, and then we have the block matrix extracted already. So, we just need to now print this block matrix. So, I will just print it. We will compile the code. We have a error here, it's saying missing an I in the data type. We compile again and run the executable, and we see that MB1 is a matrix with elements 1, 2 as its first row elements and 4 and 5 in its second row. Now, if you look at the matrix M1, we started with index 0 0. So, we started with 1 and we said we want to move 2 steps. So, 1 and 2 will be in that block matrix, and along the row also we move 2 steps. So, we took 1 and 4 as its first column, and that also goes, once we reach 4 we also took 4 and 5 by moving along the row. So, the resultant MB1 matrix will have the elements 1 2 in its first row and 4 5 as its second row. I hope it is clear. Now, suppose we want to concatenate 2 different matrices, or let me first extract another block from M1 matrix, that will be useful for the next example. So, I now want to extract another block from the matrix. However, we will not start from the row and column index as 0 0. Instead, we will be starting at 0 and 1. So, 0th row and column first. So, we will be extracting from here. So, we will be extracting 2 3 and 5 6. Okay. So, that is MB2 matrices. Now that we have this MB2, let us print out to see how MB2 looks like. So, we see that MB2 is 2 3 5 and 6. Okay, now that we have 2 matrices MB1 and MB2, which are 2 block matrices of size 2 by 2, that means they have 2 rows and 2 columns, we can concatenate them horizontally, because both MB1 and MB2 has the number of rows is equal to 2, and that is what we are going to do now. In order to concatenate 2 matrices, as I said, we will be concatenate them vertically, horizontally first, and then we will concatenate them vertically, because that is also allowed, because they have the same number of columns. So, we can concatenate them horizontally and we can concatenate them vertically. However, the resultant matrices after doing the horizontal concatenation will have dimension 2 by 4. On the other hand, if we concatenate MB1 MB2 vertically, the resultant matrix will have number of rows is equal to 4 and number of columns is equal to 2. Okay. So, concatenating MB1 and MB2 horizontally is something that we are going to do now. In order to concatenate MB1 MB2 horizontally, we first need to define another dynamic matrix. Suppose the name is concat H, and this matrix will have the number of rows same as the number of rows of the matrix MB1 or the matrix MB2 in that matter, and the number of columns will be the sum of the number of columns of MB1 and the columns of MB2. Okay. Then we are saying that once we have that size of matrix ready, that block of memory is ready, we want just to feed in the numbers in it, and the numbers comes from the matrices MB1 and MB2, and our concatenated matrix is now available, which has 2 rows and 4 columns, and now we will just print them. So, I will compile and run the code. As you can see here that this concat H has 2 rows and 4 columns, and the first 4 by 4 block matrix, that is 1, 2, 4 and 5 is coming from MB1, and the last 2 by 2 block is coming from MB2, which has elements 2, 3, 5 and 6. So, we are good here. Next, suppose we want to concatenate MB1 and MB2 vertically. So, we will have the similar procedure what we have seen in concatenating MB1 MB2 horizontally. However, in this case the number of rows of the resultant matrix will be the sum of MB1 rows plus MB2 rows, and the number of columns will be same as either the rows of columns of MB1 or MB2, because MB1 MB2 has the same columns and we are concatenating them vertically. So, we can concatenating them, we are concatenating them vertically, and the resultant matrix name is concat V, and all we have to do now is to compile. So, if we compile the code and execute, and we get the vertically concatenated matrix. I forgot to change the name in the print statement. So, let us compile the code and runs once more. So, yeah. So, we now have these concat V matrix, and this has 4 rows and 2 columns. The first 2 rows are coming from MB1 matrix and the last 2 rows are coming from the MB2 matrix. Okay. So, that is all for this video. I will see you in the next one. Thank you very much.